All right, we are live. I had to do this twice. I think my internet was wonky, but now it's working. So here we are. What to talk about? What to talk about? How to boil the world in 3 easy steps. So this is a riff on Steve Jobs. Thank you, Steve, for all you taught us about salesmanship. 3 easy steps. Dig up the fossil fuels. Step 1. Step 2. Set them on fire. There's no third step. Here's what I wanted to talk about. So, how to boil the world in 3 easy steps. I got to thinking about this and wondering if it should be discussed. And I think it's time. What stimulated me to think about this was events that are happening on the west coast of North America in terms of weather, which is kind of a proxy for climate, which is kind of a proxy for what's happening with global heating. So there's 2 steps removed. And also what's happening over in the UK and on the continent, Europe, at the same time. If you live in North America, in particular, if you live in the Western states, then you have noticed that for 2 years running, we have had some pretty crazy bad weather. Oh, well, weather comes and goes. Yeah, but not like this, it hasn't. For example, south of where I live, there's a small community, but important community of Capitola. It's on the coast of Central California, I guess you would say. Definitely a surfer community. They get big waves down there. It's cold because it's the Pacific. It's the East Pacific. It's really cold water, so it's not as nice as some other places. But the surfing is good. People really like it, and Capitola is a surfer hangout. And there's restaurants and there's bars and there's surf shops and there's all these things going on down there. It's been there for a long time. Capitola, at least the beach part of it, has been essentially wiped out twice. Both times by huge, unprecedented wave heights. Waves that are coming ashore, and they just go over all the barriers, all the boardwalks, and they just roll up the long slope of the foothills right into the community and right through the restaurants and right through the surf shops, and one after the other, one wave after another. These are not just a rogue wave that came out of nowhere. It's just wave after wave after wave for days and days and days. Twice. Actually, when I say twice, I should say 2 events. And some of these events were days long. And right now, I think they're still being pounded. So more like a week. And people who have just barely finished rebuilding from the last time this happened, same time last year, are now destroyed again. Now, these communities they're on the coast, and no, this is life. No, it isn't. Okay, these communities have been here for a long time. Some of these communities have been here, since the 49ers, since the gold rush. Okay, these were the places where the ships would come ashore, and there are still at these locations there are still piers that go way out into the ocean to unload whatever they were, whaling ships, cargo ships, whatever they were, and those docks are still there, and they're tourist attractions. And they're part of the scene. The wharf at Capitola was destroyed by waves last year, and they were still repairing it this year. The repair equipment was still on the wharf, the dock, whatever you want to call it. Goes out into the sea, right? 300 feet out into the sea. It was still sitting on it when this next round of waves came through, and some of the waves were like 30 feet high. People were saying, hey, you need to get that crane off that wharf unless you plan on being in the nightly news, because it's going in the drink. So 2 years running, These same waves have been just destroying communities all the way down California, all the way down to San Diego. Some more than others, of course, but storm surges, sneaker waves, dramatic photographs of waves completely overwhelming the seawall defenses, going right over the seawalls, right into the streets, down the street, people running for their lives, getting knocked down, sent to the hospital, flowing into downstairs apartments, flowing into businesses, no sandbags, nothing. They had no idea what was going to happen to them. No clue. No clue at all. Got beat down. That's the west coast of California. At the same time, all this has been going on 2 years running. The UK, which is a big place, right? That's Scotland, England, Wales, the UK, as well as large parts of the continent. So the Netherlands, France, Spain, they've all been in the news. And even to some extent, the Mediterranean countries, Greece, Italy. Italy's been having a hell of a time just getting beat down, year after year, just massive beat downs. Flooding, rains and flooding, and huge waves, gigantic waves coming ashore, wind-driven waves. Now, in the UK, and apparently this is somewhat controversial, and I think I understand why it's controversial. The UK started naming their storms. The last one to come ashore, it was just like a few days ago, was Hank. It's actually a Danish word, Henk. So let's all respect Danish spelling. Hank came ashore. H, A, B, C, D, E, F, G. H is the 8th such storm. And my wife and I started noticing what was happening. And we went through C and then D and then E. And we were like, wait a second, these are coming like 3 days apart, a week apart. What is going on in the UK? Now they're up to H. And you can do a search for, major storm hits Scotland. And for this year alone, you'll get a list of videos, and they'll be like a week apart in the recommendations list. They'll just be a week apart. And you'll be thinking, is that the same storm? Well, no, they're not, because there's an A storm and a B storm and a C storm and a D storm. And this is happening at the same time in the UK as the west coast of North America is getting just mangled. And so, you could say, well, okay, that's weather, not a big deal. True, it is weather. It is a big deal. These are not normal scenarios. One of the reasons that it's controversial, I suppose, to be naming storms in the UK. And these storms, they have like 80-mile-an-hour winds, 30-foot waves, huge storm surge, entire towns destroyed with flooding, right, from the storm. So you can say, oh, well, they're storms. I mean, they must be used to that. These storms, these are named storms, the way we name hurricanes. And it's a bit controversial in the UK because they say, well, we don't get hurricanes. Well, that's true. But you're getting something. You're getting something. And it looks a little bit like a hurricane. And so they're going to start naming them so they can talk about them. And so they can count them, so they can keep count. I mean, this is like a new thing, right? And, we're getting storms that are coming in like, I don't know, every 4 or 5 days now. They used to call them atmospheric rivers or Pineapple Express. And the meteorologists kind of, oh, well, this will be fun. We'll get a lot of rain, blah, blah, fill up the reservoirs. But they become really dangerous. And a lot of these storms, up until the one that's coming in tomorrow, have been essentially tropical storms. I've been in tropical storms. I used to live overseas, and I've been in tropical storms. And I can tell you what a tropical storm is like. It's warm, it's windy, the rain comes down in buckets, and it'll come down in buckets for an hour, and then it moves on. And that's how tropical storms are. Hurricanes are the same way. Tropical storms are just like that. Tropical storms are cyclones. They go around, and they throw off bands of rain, and then they'll throw off another band, and they'll throw off another band. And if you're familiar with hurricanes, you'll kind of know that the rain comes in bands. These are not like typical winter storms that we get on the West Coast, where the rain just comes in a sheet from the north, right? As the cold air pushes down, it pushes down the moist air ahead of it, and it just rains that moisture out because of the cold. And of course, you'll get snow, and but it comes through and it rains really hard for a day or two, and then when that air mass is finally done, then behind it you get freezing cold temperatures, beautiful, brilliant blue skies. Pollution is reduced to zero. The rain has pushed all the pollution out of the air, and it's cold, and you might even get. I remember this when I was growing up. You would get frozen puddles after the rain fell, and you had puddles everywhere. They just ice over afterwards. It was so cold. They just ice over, and that was fun when you're a kid. Living in California, we're not used. Valley residents aren't used to seeing a lot of ice, so that was always cool. These storms are not like that. Now, people who have been paying attention will say, "Oh yes, haha. Maybe you haven't heard of this, Mr. So-called climate scientist. Maybe you haven't heard of El Nino." Oh yeah, I know all about El Nino. Absolutely, and they will tell you that sometimes El Nino can create conditions, especially in the lower 48, the Southwest in particular, of heavy rains. And I've been through a lot of El Ninos, and atmospheric rivers and whatnot. Uh, this El Nino, even though it's an El Nino, technically speaking, it's not particularly strong. This is not a massive El Nino. This is not an El Nino for the record books and all that kind of stuff. Maybe someday it'll become that, but actually there's some sign that it's already on the way out. So you could say, "Ha, El Nino." Well, we know about El Nino. Well, maybe, but does this really qualify? Where is this stuff coming from? Where are these storms coming from? I'm getting to that. Okay, just stay with me. And what about the UK? What about Europe? I mean, they show videos of what look like medieval villages. They're probably not, but half timber construction and cobblestone roads and uh, hand hewn stone walls and all this stuff, and they show them being flooded with water. There was a place in Germany not too many years back that had water in it up to the second story windows in some of these places. Second story windows. So you could say, "Oh, well, that's just typical for them." No, it isn't. Those are 300-year-old buildings. They've never been flooded to the second story. What's going on? What's going on in Europe? What's going on in the UK that all of a sudden they have to start naming their storms? They're getting so many of them. All right. So there are what we call, when you're doing root cause analysis, RCA, there are proximate causes and ultimate causes. Proximate causes are the thing that cause the effect. And we have to be very careful with effect. Sometimes people look at effects and say, "Oh, well, that's the thing." Well, yes, global warming is something we talk about, but people talk about it as if it's a cause, and it's not. It's an effect. Global warming is something that happens after you did something else. You see, it's the effect of something you did. And what did you did? What you did was you burned fossil fuels and let the CO2 emissions escape into the atmosphere. And that created, a greenhouse effect, and that created global heating, which is something you can measure with a thermometer, right? You can't measure with a thermometer the CO2 being released, and you can't see it, you can't smell it, you can't do anything with it. It goes in the atmosphere, and it's like, wow, it's gone. What an amazing thing. And then later on, you get this global heating, which you can measure with a thermometer. So cause and effect, right? Cause and effect. So these storms that we're getting are effects of something. And a proximate, meaning a nearby effect, is changes in the subtropical jet stream. There's a polar jet stream way up north near the Arctic Circle, and there's a subtropical jet stream closer to the equator. We don't hear too much about the subtropical jet stream because it mostly affects the tropics, the equatorial countries, which are by and large developing nations, right? We don't really care, frankly. White people living in the north just don't care. Now, I used to live in the tropics, and so I had to deal with, the rainstorms that would happen. And if you live in the Caribbean, you have to deal with hurricanes, and all these things are associated with the subtropical conditions, subtropical weather, and eventually the subtropical jet stream. So The proximate cause of all the terrible storms we're getting on the West Coast is the changes in the subtropical jet stream. Basically, what it has done is rather than blowing from west to east down near the equator, it has moved north a bit, and now it's blowing west to east, further up, closer to the lower 48 states. In fact, maybe even a little bit up into the southwest. So it's blowing up high. The same thing certainly happening over in Europe and the UK, right? The subtropical jet stream, the same phenomenon we're seeing in the lower 48 states, it has moved north and it's blowing across parts of continents. The developed world, now we're talking about the developed world. We're no longer talking about the tropics where, you know, countries are that people can't even find on the map. Talking about the developed world now, the subtropical jet stream has moved north and it's blowing through these areas now, and it's bringing with it subtropical conditions because that's what these jet streams do. When the polar jet stream descends south a bit, then it brings freezing air with it. It acts as a fence, it acts as a border. The Talking about the polar jet stream, the polar jet stream acts as a fence. Above that are polar conditions, and below that are temperate conditions. And the winds that are blowing at really high speeds around in a circle kind of demark where the transition is. Okay. When the polar jet stream fails for any reason, becomes wavy or putsy, or it slows down, or it breaks into two different rings going in different directions, then some of that polar air can escape, can basically break through like a horse breaking out of its corral. It can break through and descend further than it normally would. And then you get these monstrous freezes in Europe, and terrible freezes in the UK, and horrific freezes in the Midwest and in the lower 48 states. And that's when the polar jet stream collapses or breaks or shifts south. When the subtropical jet stream shifts north, it brings with it the conditions that used to be locked and kept in the tropics. And so that's warm, moist air, right? So the proximate cause for all this weird weather, we're getting all these high winds and all this rain and all whatever else is going on with these storms for several years running now. The proximate cause is that we are experiencing an increase in influence in these zones of tropical characteristics. El Nino. We've had El Ninos before. El Nino can change. El Nino, which is a aspect of the South Pacific, because the South Pacific, because the Pacific Ocean is so large, it can have an outsized influence on global atmospheric dynamics. So when this South Pacific experiences a change in the ENSO, the El Nino Southern Oscillation, it can affect the global the global temperature and the global behavior of the weather patterns. One of the things that happens is that the subtropical jet stream shifts north, and it brings tropical conditions with it. And so, the proximate reason for the changes in the storm patterns we're seeing is because of the emergence of these tropical conditions moving north into areas of the developed world. This is very important. That's where all the news is, right? Into areas of the developed world people care about. And suddenly you're noticing, suddenly you have major named cities that are being flooded, and cars are floating out to sea with people in them, and people are climbing on top of their cars and floating out to sea. And you're like, wow, that's crazy. That's happening in Spain. That's happening in Italy. That's happening in Greece. That's happening in Germany. And you're looking at that and saying, haven't seen that before. No, you haven't. Probably happens in other places, but you just weren't aware of it because it was further south in the tropics and you didn't care. Actually, they don't have these kind of problems. They're adapted to it. They're adapted to these kind of problems. They're kind of used to it. In the same way that if you go to, say, Louisiana or Mississippi, you'll find that the coastal houses that are right near the beach, are on poles, stilts, if you would, so that when there's a storm surge from a hurricane, which they get fairly frequently, the storm surge just goes under the house, and then it washes back out to sea, and the house is left high and dry. And maybe you're in the house while all this is happening because you've seen this happen before. So Areas that are accustomed to these kinds of assaults and these kinds of abuse adapt, or of course, the people leave. There are places, I suppose, that are uninhabitable because of the behavior of the Earth system in that particular location. But the Saudis have been getting floods and massive hailstorms. Is that normal for them? I was never aware that Saudi Arabia flooded 8 times a year. I've never heard that Mecca, their holiest shrine, it floods and people have to run for cover and all this kind of stuff. That seems kind of new to me. I don't know. Is it new? Maybe it's not. I'm not from that part of the world, so don't really know. But I know that the UK is up to their eighth named storm, and these storms look a little bit like hurricanes or tropical storms to me. And they're naming them. They're worried. They're starting to number them. And it's really controversial in the UK. I'm sure there's people who say we shouldn't be naming these storms. You're giving them too much credibility for being important. If you start naming them, and pretty soon you have them move into your house and live with you, Well, okay. But I think they're trying to make a point that we need to start counting these things. We need to start keeping track of these things. And it helps people to understand what's happening to them. To understand that these are unique, they are new. After about the sixth or seventh one, they start to blur together in your head, right? Did you hear about that storm last week in the UK? Oh yeah, well, that wasn't there one a month ago? I don't know, I can't remember. I just remember the one from the 2 weeks ago. Oh yeah, and then there'll be another one next week, and then you'll forget the one further back. But if you name them, now you have a tool, right? You have a tool for assessing what's happening to you. So yeah, it's a little controversial in the UK to be start naming the storms. Why are we naming the storms? You're going to have them move in with you, but there's a reason for that. Now, here on the west coast of California, the surfer village of Capitola was essentially destroyed twice. Is that normal for them? Don't think so. Again, I'm not from that part of the country, but it's fairly close. And, it's in the local news here, right? When it gets wiped out, it makes the local news. It's in my news feed for my area. And so I don't know. I don't think it's normal for them. I think this is unusual. And this El Nino is not that big a deal. It really isn't. There's something else going on. I've said in earlier videos that last year something broke. I don't really know what it was. I haven't heard any convincing arguments about what it was that broke. Something broke. The collapse in the ice extent in Antarctica was amazing. People were gobsmacked. They were like, what just happened? They don't even know. It was so bad, and it came so far out of left field that they were just, what? Are you seeing what I'm seeing? What is this? And when scientists who really keep their finger on the pulse of their work and who have all the instrumentation, they have all the satellites, and they get the data every day, and they publish papers frequently, and they go to consortia, and they go to gatherings, and they talk about their work, and they talk about changes. When those guys and gals, when they're all sitting around the breakfast table, and they're all looking at the news and looking at the data and saying, what? What do you mean? I mean, you and I can be surprised by something. The people in Capitola can be surprised by something. But when the scientists are surprised by something and they're going, what? Did you see what I just saw? What is that? Okay. When the scientists are doing that, well, you better pay attention. Last year, some shit went down in the Antarctic that had people gobsmacked. It was literally we are off the charts. We are off the edge of the map, people. We don't know what happened. This is really screwy. This is scary. This is something terrible. And now, 2 years in a row, Capitola got wiped out. What are we supposed to think about that? Well, it's all just random data. And, if you look at enough data, you're going to find patterns however you want to find them. I'm not looking for patterns. I'm just sitting back and being amazed. I'm being amazed at what's in the news just every single day, every week, all the time. It's like another goddamn thing has happened. Wait, Is that 2 storms? Is that 2? We're up to H, we're up to Hank, and what is I thought they had one last month. They did. They got wiped out last month, and they've been wiped out this month, and I guess they'll be wiped out next month. How many more storms do they have in them this year, this storm season in the UK? I guess we'll find out. Until Capitola got wiped out 2 years running. Okay, that's a thing. Something is broken. Hmm. Something is broken. I wonder what. Now, I hear all these optimistic prognostications from climate scientists. They feel like they got a handle on this, and Greenland's not going to melt until the year 2300. I mean, I've been hearing this kind of stuff since I was 28 years old, getting my master's degree. Okay, in biology. And we talked about this back in the late 80s, and people were kind of waking up to it. And the fossil fuel industry had been already sitting on data for 20 years at that point or longer. And people were starting to talk about it, at least in the scientific fields. We're starting to look at the data and looking at what was happening and saying, this is interesting. And so we've been having these conversations for a long time. And it was always, oh yeah, it's 300 years off. Any real problems we won't really notice for hundreds of years. It takes a long time. They change the climate. The atmospheric forcings are really slow and putsy, and the oceans are huge and they absorb a lot of heat and a lot of carbon dioxide, and it's going to take a long time. And we need to monitor this, and maybe we should create an IPCC process to monitor the science and make sure that nothing falls under the radar, so we can keep visibility on this, and just see where it's going. And in 100 years or 300 years, maybe we have to take evasive action, but for now it's fine, business as usual. And drive, fly, do whatever you want. And there are still people who will tell you, oh yeah, real changes from global climate change, yeah, that's decades out. The year 2050 gets popped up a lot. The year 2100 gets popped up a lot. And no, that's not true. I mean, I can see why people would say that, because we've never done this before, right? So you kind of think, well, humans are puny, and our fossil fuel consumption doesn't seem like it's that big of a deal. And, fuel efficiency in cars is always improving, and excuse, hand wave. And, hundreds of years. And then they look at other times when the climate has changed globally. And when they look in the record, the soil record, they can't, the rate of change is so fast, they can't even see it. There's no gradual anything. It's just, you have one climate regime here, and then you have another climate regime above that, and there's just no transition. And there's some evidence that, and I've seen this number discussed. There's some evidence in the paleoclimate record that these changes, well, they might take 10,000 years, and then they're like, well, actually, it might be just a couple of 1,000 years or less. And then people were saying, actually, we don't know how fast the global climate can change. It could be abrupt. And abrupt could mean, a couple of decades. It could mean even less. It could be almost, geologically speaking, it could be instantaneous. So as scientists have gradually reduced the time they think it takes to make these changes, in the paleoclimate record, we see in real time playing out that all the estimates about, well, we're not going to see changes until 2100. Well, actually, maybe more like 2050. Well, we should really be reducing our fossil fuel emissions now, because by 2050, it could be really bad. Actually, we could see major changes by 2030. Actually, right now, we should be our fossil fuel consumption would be cut in half. And that's the trend now, is all the estimations are reducing, always cutting it in half, sooner. And then something in the Antarctica broke. I haven't seen any convincing discussion of what that was. It's still broken. I have I don't even know. I haven't heard anything, and to be honest, I can't even think of something. Well, ocean currents, uh, storm tracks. It could be anything, but without data, you're just guessing, right? And at the same time, that's happening. We're getting these massive storms coming ashore on the west coast of the U.S. and on the west coast of Europe, including the UK. Another set of massive storms coming ashore, and there are rainstorms falling all around the planet. Huge, monstrous storms. Uh, Rain, flooding, occasionally hail. Now, hail is just precipitation. Hail, that's ice. Well, you can get massive hail in hot climates because hail has nothing to do with the temperature on the ground. Hail has to do with the temperature at high altitudes. And when the atmosphere is so violent with convection, violence, which is another way to say has a lot of energy. When the atmosphere becomes violent, rain, which would like to fall down under the influence of gravity, falls up under the influence of violent convective currents. And it gets thrown high up into the atmosphere, 80,000 feet, whatever. And it freezes solid before it comes down again. And it can rotate in a loop, falling and rising and falling and rising. And hailstones can get built up until they're this big around. And then finally, the convective currents don't have enough energy to keep them up there long, and they come down under the weight of gravity. Gravity wins. Of course, we all know gravity always wins, right? So eventually the hail comes down, and you can get hailstones, in the desert. You can get hailstones that are the size of golf balls. And that's what's happening all around the world. There are some nations that get flooded out with rains, 10 inches a day, 1 inch in 3 hours. And sometimes they just get beat down with hailstones, which is just another form of rain. And what the hailstones tell you is that the atmosphere is violent, huge convection. Another symptom of increasing energy in the atmosphere and increasing violence as a consequence is that airlines, commercial airlines, are reporting increases in damaging turbulence. Now, you know what turbulence is. If you've ever been on an airplane, if you've flown airplanes very often, the plane can be made to bounce up and down. This is because of turbulence in the atmosphere. The planes can do pretty well flying into the wind or with crosswinds or even tailwinds. And planes have flown at high altitudes through the jet stream, which is a really fast wind, and not had a lot of issues with the jet stream because it's just a laminar flow. It's high speed, but it's laminar and you just fly right through it. You have to steer differently, so as not to be blown off course. But steering is something that they can do just fine. That's why they have rudders. So they steer course, and the wind's blowing from the side, and they just fly through the wind, and you barely even know as a passenger that that's what's happening. Turbulence is different, and turbulence is increasing. Turbulence is violence in the atmosphere. It is a sign that the atmosphere is unstable. So there, in addition to all these laminar airflows that go across, there's up and down and up and down, and it beats the planes up. And there is increasing incidence of people being damaged in airplanes and being taken to the hospital because of these violent turbulence. Basically, if you're going to fly in a commercial airplane at any altitude, it's not just some regional flight, but you're going to be flying across continents. You need to keep your seatbelt on all the time at this point. The cabin attendants can't do that because they're walking up and down the aisles and they're pushing the drink cart and they're attending to people's needs. So they just get beat up. They just get thrown against the ceiling and then thrown against the ground and thrown against the ceiling again. And, it's just coming out of nowhere. Violence in the atmosphere. More of it, increasing rates of injuries due to violence in the atmosphere. And then you see golf ball sized hail falling in Saudi Arabia, in the desert, so thick that they can shovel it in the desert. That's a symptom of the same thing. Now, these are all effects. You can't do anything about these things. And you can't do anything about the turbulence in the atmosphere. That's now a permanent feature. That's never going away. All that will do is get worse. So what's the cause of these things? The cause of these things is that the Earth is heating up, and the energy in the Earth has to find somewhere to go. You boil a pot, you put a pot of water on the stove and you turn up the fire, and what happens to it? It doesn't just heat evenly all the way through until finally it's you know really hot at the top of the water. No, it heats at the bottom. And then when the bottom gets hot, the hot water rises. And when it gets doing this a lot and you get bubbles, you get violent churning of the water. And when you heat the pot at the bottom, which is how the earth heats, or her earth heats at the surface, not in the high atmosphere, in the surface. When you heat the pot of water at the bottom, or you heat the earth at the surface, you get the same effect. You get violence as these exceedingly hot areas rise and do work. They're basically moving air masses vertically, and this is a new thing for us. It's this violence that causes the subtropical jet stream to move north. Now, most people don't know this, but there was a time when the Earth was essentially the same temperature from pole to pole, meaning from the pole to the temperate to the equator to the temperate to the pole, all the way down, all the way up, was pretty much the same climatic zone. What would have been tropical or subtropical, maybe? Okay, that there was no ice, to be sure. There was no ice anywhere on the planet, and the seas were at least 270 feet deeper than they are now. Continental edges were underwater, entire continents were underwater, and so on. That's where we're going. As we keep heating the planet, there's going to be a kind of boiling for a time. There's going to be this boiling mechanism where the heat that's being collected in one place is trying to get out, and it's moving vertically, and it's starting to heat the atmospheric column vertically, and then it's going to spread out from the equators and the temperate zones. It's going to spread out to the poles, and this is going to be violent. This will be violent. The violent turbulence in the air that the airlines are seeing is a symptom. It's an effect of the thing, which is that we are heating the planet. And the heat in the planet isn't going to stay where it starts, just as the hot water on the bottom of the pot doesn't stay there, okay? And it doesn't rise gradually to slowly heat the entire pot contents all the way to the top. It becomes violent. The heating is too intense and it becomes violent. And as we heat the planet intensely, rapidly, with no effort on our part to slow that process at all. There is zero. There's a lot of talk, not even a lot of talk, there's some talk, but there is zero effort. The actual number is zero that we are trying to slow this process down. And as the heating becomes more intense and more concentrated, then the response of the Earth dynamic system will be violence. And the way you will see violence working itself out on the surface of the planet where we are will be Capitola wiped out 3 times. All right? Last year, this year, and sometime soon. Now, the tragedy, of course, will be that they'll keep coming back. The insurance companies will keep paying out. They'll keep rebuilding. And it's a tourist attraction. They'll be rubbing their hands together with glee. The tourists are going to come back. And then, bang, the waves come back too. Maybe next year, maybe the year after that. It's hard to say. This current El Nino is beginning to already calm down. But at some point, you won't be able to point to, oh, well, it's El Nino. Oh, well, it's sunspots. Oh, well, it's something else. No. It's the Earth heating, and that heat has to go somewhere. It has to do something. And it will not stay where it originated. It's going to climb into the atmosphere. It's going to make the Hadley cells spread further north and south. It's going to descend with greater violence. It's going to sweep across the planet on the way back to the equator to go back up again and collect more heat, spread it even further. Pretty soon, the subtropical jet stream will move north and north and north, or further on the other end, south and south and south. And that will become a permanent feature. That won't just be something that happens every so often. That'll become a permanent feature. The violence in the system is causing the tropical zone to become dominant. While there's ice in the north and there's ice in the south, this process of the tropics, the heat in the tropics dominating the entire Earth system is going to take a little while because there is ice that has to be melted. The ice tends to maintain the cold in the north and the cold in the south. But as that ice melts, there's less work to be done by these hot currents that are trying to get to the poles, trying to do work, trying to dissipate themselves by doing work like melting ice or heating cold water. As these features of the Earth system, ice and cold water, begin to be consumed, the ice melts, the cold water gets warmer. As this happens, then the effect of global heating will be felt further and further away from the tropics. And the symptom of that will be, where is the subtropical jet stream? Remember, it's the fence that is the border between the tropical conditions, the tropical regime, and above it, the temperate regime. And above that, the polar ice-dominated regime. And so as the tropical system, the tropical component of the Earth dynamic system becomes more and more energized, as it becomes more and more violent, with more energy, having to go somewhere, having to do something. As the tropical belt becomes more violent, it will enlarge like this. Like a boiling pot of water. It will dominate. And eventually, when the subtropical jet stream has traveled, through the lower 48 and it gets into Canada and it keeps going north and it keeps bringing all this warm, moist air after it because it's a fence and it just keeps rising. Eventually, the tropics, we won't even call it that anymore. The tropics will just extend from the equator all the way to the pole, like it used to. Just like it used to. That's how it used to be. This ice-dominated regime that we've been in for, well, not we, but that the planet has been in for about 2.5 million years. That's only 2.5 million years. The Earth is 4,500 million years old. Well, actually, the Earth is older. Well, yeah, that's about the age of the Earth. 4,500 million years. And for about 3 million years, 3 is a much smaller number than 4,500, okay? We've been in, this ice-dominated system, which created, the freezing poles, the dry temperate zones, and then left a remnant of warm tropical belt right around the equator. Well, now because of the greenhouse effect, that tropical belt is getting bigger. It's extending north and south. And evidence of that will be things like, where is the subtropical jet stream? Where is it today? Where is it this year? All right. That is the movement of the subtropical jet stream. Then the impact of El Ninos and the occurrence of named storms. These are all effects of an ongoing, constant, unabated, unstoppable, really, heating of the planet. At this point, it's unstoppable. You would have to remove CO2 from the atmosphere, and you can't do that. Nobody can do that. We don't know how to do that. Nature can do that. Erosion, give erosion 100, 200, half a million years, and maybe it'll remove enough CO2 to cool the planet and reduce the greenhouse effect and cool the planet. Maybe. Yeah, maybe. But maybe not. We don't know. I guess we'll find out. Well, maybe we won't find out. Maybe humans don't survive this transition. We might not. We didn't evolve in the tropics. Humans did not evolve in the tropics. Humans, upright, bipedal, walking primates, we evolved in the savannas, more temperate zones, grasslands, drier, seasonal rains, and we followed the herds. We ate the herds. We ate the animals that were in big herds. Monkeys, chimps, Gorillas, they live in the forest, they live in the jungle, and they eat whatever's at hand. And sometimes they eat meat, or they otherwise they eat plant fruits and vegetables, and they lay around and digest their food all day. And sometimes they get a meat meal. The chimps apparently are a little more likely to go hunting than say gorillas, or I think gorillas are strict or herbivores, and the orangutans are frutivores or something like that. Some combination of things. The chimps are hunters. And we have more similarity to chimps, and we are definitely hunters. And that's how we evolved. We evolved on the savannah, which was a temperate zone. And we were evolving for that habitat, starting about 4.5 million years ago. As the Earth had been cooling for about 20 million years, the Earth had been cooling. And during that time of cooling, we migrated out onto the savannah, which was sort of a new thing. The Earth used to be tropical. All forests, dense jungles, dense forests, lots of food if you could climb trees. And then, that wasn't for us. We evolved upright walking. You don't need to be upright walking when you're in a dense forest or a jungle, right? What's the easiest way to get around? It's called brachiation. And you just swing through the trees, right? Monkey swinging in the trees. And you have these long legs, long arms, shorter legs. Your feet and your hands are both about the same. They're curved like this, so you can have good ability to hook onto a limb, and you got really long fingers, and you're not really gripping as much as you're just doing this. And so you're brachiating in the trees, you're swinging from tree to tree and taking advantage of the vines and taking advantage of the branches, and sometimes you're on the ground, but mostly you're up in a tree. And who else is on the ground? Well, down that's where the jaguars and the lions and the tigers are, right? So you don't want to be down there. You want to be up here because it's where the fruits are, and the bird nests and small mammals that you can eat if you can catch them. Lizards, frogs, right? And that's how we lived in the jungle. You don't live in the jungle by doing this, walking on two legs. Okay, that puts you down with the tigers. That's stupid. So you're up in the trees. You're brachiating with your arms like this. And it wasn't until the savannah became a thing, as the Earth cooled, as the Earth cooled for 20 million years or so, and eventually went into ice ages. As the Earth cooled, then the savannah became a thing. The grassland became a thing, and then crawling around on your four limbs wasn't as advantageous as being able to stand up and walk on your hind limbs. And that's where humans evolved, on the savannah, because of global cooling, because of the coming ice ages. And we did really well. That's us. That's our habitat. Grasslands. That's our habitat. We've never really done well in the forests and the jungles. It's not an easy place to live. Not an easy place to have a family, not an easy place to have a tribe, not an easy place to have a civilization. We just don't do that. And we evolved as the planet was cooling. And after that, with the intermittent ice ages, where the ice would come down and then it would go back and then it would come down, we did pretty well, right? It got us where we are today. Here we are, doing our thing. And as the Earth gets hotter, as the tropics get bigger, you need to imagine that we kind of get pushed off the Earth. As the tropics enlarge and the forests and later the jungle takes over, we will be moving just outside that. Because we have row crops and we have domesticated animals and we have cities and roads and trains and airports. And, we can't do that in the forest, in the jungle. We can fight the forest, we can fight the jungle, we can cut them down, we can set them on fire, but it's going to be a constant fight, right? So mostly what people will do is they'll just move. When the jungle comes in and it takes over your fields and you're out there hacking weeds all the time, but a little further north, the farmers aren't having that problem, well, then you give up. And you want to sit there hacking weeds all the time and digging up weeds and hacking the tree roots and digging up the stumps, and forget it. It's too much work. So you go to the north. If you live in the northern hemisphere, you go to the north and you buy some land and you set up your farm and you till your crops there, and you have your domesticated herds there, and you have your cities and your freeways and your airports and your whatever else. And over time, as the jungles and forests get deeper and thicker and more aggressive, and as the rains become a real problem, which is another thing that happens when the tropical areas become dominant, they bring the rains with them. The tropics can actually create their own weather. Yeah, but this is a losing proposition that eventually the tropics just sustain themselves. The Amazon rainforest just makes its own rain. It makes its own rain, and it's always a rainforest until you burn huge holes in it. The Amazon rainforest makes rain. That's what it does. And so you start to lose this battle. You just can't win. And so as the tropics extend further and further north every year, we kind of have to move with it. Our habitat zone, which is open grassland savannas, moves right along with it. And pretty soon, your areas where you can grow wheat, which are currently in the temperate Midwest, or you can draw a line right across the planet, where they can grow wheat. It just starts to shift its way north, and pretty soon you're into Canada, and you're growing your wheat in Canada. Oh, but wait, Canada is a boreal forest. Canada, so this is all in respect to the U.S., but you can have similar discussions in Europe and similar discussions in Eurasia. Canada is a forest. So what's going to happen to us is that we Americans, with our wheat fields and our corn fields and our soy fields and our huge feedlots for animals, we're going to get crushed. The boreal forest up north is not suitable farmland, period. It's forest. It's suitable for forest, but that's not the same thing as farmland. You'd have to clear a bunch of trees. You'd have to cut them. You'd have to dig the stumps out, and then you'd probably have to build up the soil. Soil building can take hundreds, even thousands of years. So, as the tropics come up from the south and start to make human habitat, starts to destroy human habitat, the stuff that we're accustomed to, right? The dry, temperate, seasonal rains, long growing seasons. Okay, as that starts to disappear, then we start to migrate north ahead of that, and we hit the boreal forest, and then eventually we just get crushed out of existence. That's an effect. You can't fight that. You can't fight that. That just happens. That's the outcome. That's the effect of global heating. Eventually, of course, the entire planet becomes the same temperature. And then the violence ends. Curiously enough, the violence ends. There may be different kinds of violence, maybe. Hurricanes become more of a thing. You could spawn hurricanes almost anywhere. Florida recently, 3 weeks ago, got clobbered by they didn't, the weather people, they're such putzes. They wouldn't even talk about it as like a tropical storm, or as a hurricane that didn't quite form, or as a tropical storm. They just called it rain, a storm. But it was a tropical storm. It had circulating winds, it had rain bands, it was violent, it was high winds, and it went right across Florida and rained and did all these problems, and it went right up the East Coast and rained and caused all these problems. Just kept going, kept going, kept going. And God forbid that it made its way to Greenland. Tropical storm coming ashore in Greenland and raining on the ice. It's like the worst possible scenario. You think it's going to take 10,000 years to melt Greenland? Not at that rate, it's not. They're already scared spitless about what's happening in Greenland. Imagine if tropical storms start coming up the East Coast and landing on Greenland and raining 10 inches of tropical rain on Greenland, on the ice sheet. Just try to imagine it. Just try to wrap your head around that. It's really difficult. But that's kind of what's happening. We're getting tropical storms spinning up off in the Gulf of Mexico, and apparently off the coast of the UK, that are just violent storms that bring amazing, unprecedented amounts of rain. Violence. And this is inevitable. This isn't a freak. This isn't El Nino. The El Nino is already going away. It's weak. It was putsy. It was never a strong El Nino. We've had strong El Ninos lots of times in the past and didn't have these kind of problems. And something broke in the Antarctica. It really did. People are still looking at that and go, what? Did you just see what I just saw? What do you think of that? I don't know what to think. I'm asking you. Okay. They still don't know. Now they'll figure it out and they'll publish a paper and we'll all get the data. Say, yeah, that's interesting. Stroke your beard, stroke your beard. That's very, very, very fascinating. And so they'll figure it out. But what's really happening, the real narrative here, the real story is that the Earth dynamic system is on the move. And where it's moving to is the same climactic regime, more or less, from pole to pole, like it used to be back when there were dinosaurs at the poles. Dinosaurs at the poles. There are dinosaur fossils on Antarctica. There are coal deposits on Antarctica. You only get coal when you have forests. And there are oil deposits and natural gas deposits in the Arctic that everybody wants. We're going to go up there. We're going to drill, baby, drill. We're going to get that oil. We're going to get that natural gas. We're going to sell it. We're going to burn it. What's it doing up there? You ever stop to think about that? And when you release all that carbon that was stored in the Arctic Ocean, in the seafloor of the Arctic, when you release all that, you're adding to the problem of greenhouse gases, and the ultimate destination of that is that the planet is going to heat up until it's as hot as it used to be before there was ice. And then you're not going to have any ice. And then you're going to have 300 feet of sea level rise. And then it's going to be the same temperature from one pole to the other. And it's all going to be violent. And you're just not going to be able to understand the violence. The violence is just going to be incredible. It's just going to be amazing. The pot is boiling. The pot is going to boil. Put a pot of water on the stovetop. Take a little dry leaf from outside, put it on that water. It'll sit there like a little boat. So cute, right? You're floating around. You can push it with your finger, push it this way, push it that way. Your little boat, your little ark sitting on the pot of water. You turn up the heat under that water and watch what happens. Pretty soon, that leaf is going around and around and around under the boiling water, churning with the convection of the water. And that's you. That's you. That's your life. That's your civilization. That's everything you ever thought was forever and stable and sacred and eternal is now on a boiling planet. Now, that doesn't mean that the seas are literally going to be roiling with boiling water. When I say boiling the earth, I mean that you're going to see violence. You are seeing violence now in the Earth system, not in the year 2100, not in the year 3000. Now, 2023 going into 2024, we are experiencing violence from the Earth system. That can only increase because this planet will eventually be one temperature from the pole to the pole. And on the way to that condition, on the way to a more stable regime where suddenly the energy is fully distributed, the earth has now got a whole new set of circulation patterns, the ocean circulations have changed, the atmospheric circulations have changed, the precipitation patterns are different, and and the temperature is all the same from pole to pole, more or less, same climactic regime, and the violence will settle down. But on the way to that outcome, that new dynamic system, on the way to that new equilibrium, we will undergo a series of violent transitions. Violent. I've mentioned this before. I'm going to mention it again because it's on my mind sometimes. I think about it. When I think about how violent could it get, I remind myself, this is how violent it could get. The planet Jupiter has a storm. Astronomers with their crappy telescopes, when they observed Jupiter, and it was kind of blurry and grainy, and they were just watching it night after night, and they noticed that as the planet went around, there was a spot on it, just below the equator, south of the equator by our reckoning, and a spot. It was a red spot. Jupiter's kind of a brownish gray, and then there was this red spot. You could tell that the planet was rotating, and you could even time its rotation by watching this spot go around and around and around and around. Then it would be on the back, and you couldn't see it, and then it would come back from the side and go around and around. The Great Red Spot. And then they would show you, oh, it's great. It is so big. It's 10 times the size of the Earth. You could put 100 Earths in the Great Red Spot, or things like that. I don't even know. There's some comparison. Multiple Earths would actually fit inside the Great Red Spot. But they didn't know what it was. Now they kind of know what it is. It's a long-lived storm. It is, to give it another name, it's a hurricane. And the winds are, 800 miles an hour. The winds are like supersonic, like the Concorde. The winds are at the limits of what the atmosphere on Jupiter can even generate. And it's just a long-lived storm. The Great Red Spot is a hurricane. And I don't know if it was because of the sudden understanding of what the red spot was, or if people were simply working in a slightly different way, working on their own work. But I don't know, climatologists, maybe meteorologists, came up with the same idea as that would apply to Earth. The same idea. Maybe completely separate from the astronomers looking at the red spot. Meteorologists and climatologists on Earth came up with a similar idea for Earth. And it's called a hypercane. A hypercane, not a hurricane, a hypercane. Trying to use the same terminology, right? It's a new term. A hypercane. You can look it up. Look it up on Wikipedia. And we've never seen one on Earth. It's strictly theoretical at this point. Strictly theoretical. We can talk about it, but we're talking about it in theory only. Okay, we've never seen one. The conditions are really extreme to create hypercanes, but we know they could exist. The atmosphere, if you look at the conditions in the atmosphere, you can kind of draw a line and project out to this other type of storm that's possible. Given the interactions between the ocean and the atmosphere, you could kind of draw a line between all the category 1, category 2, and category 5 hurricanes. And somewhere out there in hurricane land, beyond category 6 and 7 and 8 and 9, there's something called a hypercane. If conditions were ever such, and it was this hot, and the winds were doing this, and atmosphere depth was that, and the shear was this, and the jet stream was doing something else, then you could get a hypercane. It's theoretical. It's just fun to think about. We're nerds. We like to think about things that are fun. We get drunk and we talk about things, and we thought, oh, let me tell you about the hypercane. You ever heard of a hypercane? Well, I wrote a paper on the hypercane. Let me tell you about the hypercane. And that's what we do, right? We're nerdy scientists. We like to talk about fun things. Hypercane, it's completely theoretical. What is it? A category 10 hurricane? Who knows? Well, did you know that hurricanes are getting so violent, and they're called typhoons in Asia, and they're called cyclones in the southern hemisphere, but they're all the same thing. These cyclonic winds, I'm talking about hurricanes for now because I'm North American. Hurricanes are becoming so violent that there's talk in meteorological circles of adding another category, a category 6. Now, they didn't need a category 6 before. Now they're thinking maybe they need a category 6, hemming and hawing and stroking their beards. I wonder if we should add another category. I wonder why they're having those kinds of talks. And after they've added category 6 and a couple of more decades have gone by, or maybe even less, and they say, well, category 6, that didn't really cover it, does it? We've had some storms that really are beyond category 6. So maybe we should, maybe we should talk about adding another category 6.5, I don't know, 7, maybe we should just add 7 and 8 while we're at it. So where's that going? And why is that happening? And why is it happening now? And why are these terrible storms coming ashore in the UK? one after the other after the other. And why was Capitola destroyed twice? Just knocked off its foundations 2 years in a row. Oh, well, it's El Nino. Oh, well, you're just a doomer. Well, you're just extrapolating. You just have no evidence for this. I'm just axing. I'm just axing. Why is it happening? You ever think about that? Because it is. Oh, yeah. Oh, it's definitely happening. And they're going to add a category 6. It wasn't my idea. I just heard that's what they were going to do. And somewhere out there, on the way to the climactic regime is the same from pole to pole. On the way to that destination, on the way to that new Earth dynamic system, okay, that new equilibrium, okay, whatever that is, somewhere along the line of getting to that new Earth system sleeps the hypercane, I think. Violence, you see, violence is how we get there. We don't get there slowly boiling the pot. This is going to happen very quickly. It's already happening very quickly. People are already sitting back and asking, what the hell just happened? That's what they're doing. They're naming storms in the UK. Capitola was destroyed twice, back to back. Well, well, well. Am I the only one connecting these dots? Maybe I am. I do that. Oh, yeah, I do that. I can do that. I'm really good at that. I'm really good at collecting a lot of information and just sitting back and saying, now, hold on. Just wait a second. These people are surprised. These people are flabbergasted. And these people are gobsmacked. And Capitola was destroyed twice, 2 years running. They're naming storms in the UK. They're talking about increasing to a category 6 for naming hurricanes, for labeling hurricanes. And all this is happening in like the last 5 years. I just wonder, is it just me? Am I overthinking it? Or is something happening here? And ultimately, if we keep pumping fossil fuels in the air, or maybe even if we don't keep doing that, it's possible that now this is inevitable. At some point, this Earth system goes back to a status it had, 20 million years ago? Where it was the same temperature, basically, from the poles to the pole. It was a completely different Earth system. It was basically all forests and jungles, and there were dinosaurs and alligators living at the poles. That's where we're headed, because that's where we were before humans evolved. And sometime after the dinosaurs were driven to extinction by a meteorite, and before humans had evolved, somewhere in that period of time, the Earth was the way I just described it. And we are going back to that because we are digging up fossil fuels and setting them on fire. And there is no step 3. Boiling the planet. I guess we'll see, won't we? My wife is back. I'm going to end this. Have a great winter. Try not to die.